I love you, my mommy, daddy, my new paw. All right, parametrics. This is section 11.7, the end of the conics chapter. It really ties together vectors from chapter 10, okay? Parametric equations that we talked about way back in chapter 3, I think. Okay. And the conics we've been doing. So, I like that we can show an application for the vectors and the parametrics. Okay. Here we go. This is just a quick review to start out with, and then we're going to apply one more step to this that we haven't done in the past. Remember when we said things like let x equal 2 times t, where t is defined to be, and it might have said it like this. But I just wrote it in interval notation because I was being lazy. And y is 4 minus 3t, and then I even went over here and put down a few points for us, okay? So we used to have little charts like this, and we'd say between 0 and 4, find x, find y. So it says for x, we double t. So 2 times 0 is 0, 2 times 1, 2 times 2, 2 times 3, 2 times 4. Think I got those right? Okay. Then it says put t in here and figure out what y would be. So 4 minus 3 times 0 is 4. 4 minus 3 times 1 is 1. 4 minus 3 times 2 would be negative 2. 4 minus 3 times 3? Negative 5. Okay. And then 4 minus 12 would be negative 8. Okay. I think I made my little scale like 4 here or something, just so that it kind of fit, okay? So 0, 4 was up here, and 2, 1 would be over here somewhere. 4, negative 2 would be down here. 6, negative 5. 8, negative 8. Okay. We're getting a little line segment, guys. Oh my goodness, I can't draw straight. All right, so that you've all done this before, chapter 3. The endpoints were where? When you put in t equals 0 and you put in 4, we ended up with 0, 4 at one end and 8, negative 8 at the other end. And the calculator will help us do that, the endpoints, as long as we set, remember, the t max and min to 0 and 4. Okay? Now, eliminate the t. This is the new business. Really easy for this particular question. It says x equals 2t and y equals 4 minus 3t. Great lead into the next chapter where you solve by substitution. Okay? If we make this say what? T equals x over 2. And we plug that in here, it will say y equals 4 minus 3 times x over 2. Does that seem like it's a line whose slope is negative 3/2 x and there's positive 4? Does that look like what's going on over there? Okay. You can leave it written like this. I don't care. I just rewrote it so that you recognize it as equation of a line. What? We had to solve that equation for t before we could substitute it into the other one. Does that seem okay? So the idea is solve one equation for t and substitute into the other one.
And you don't have to be in any specific mode to graph that.
You would want to be in parametric mode. The degrees and radians don't matter. Is that your question?
Yeah, like no, you don't want to be a forward mode then.
No. You have to be in parametric to be able to put in the t. Otherwise, it won't give you the t. We'll do one on the calculator in a minute. All right, let's do this one by hand. What are we going to put in our chart for t? -2 to 5. Isn't that what it says to use for t? Did I leave enough spaces or not?
Yep.
Okay. I see a squared in here. Is anybody thinking this might not be a line? Okay. I see a squared, maybe a parabola. All right, I'm going to do the y's first because I'm lazy. I'm going to do the easy one first. It says square them all to get the y value. So this would be 4, 1, 0, 1, 4, 9, 16, and 25. I'm a square, yep. All right, now we're going to do 3 times the t plus 2 to get the x. So 3 times -2 is -6 plus 2, -4. Did I get that one right? Okay, put in a -1. 3 times -1. Don't we get -1?
Yep.
0 plus 2 sounds like 2. I can get that one. 3 times 1 plus 2, I think, is 5. 6 plus 2 would be 8. How am I doing? 11. 14 and 17. Okay. We may have to use a big scale again. Okay. If we go by 4s maybe again, I don't know. I'm just picking something. It's probably still not going to fit. So -4, 4 would be up here. -1 would be down here somewhere. Over 2 and up 0 would be here. Am I doing this right? This seems kind of funky. Over 5 and up 1. Over 8 and up 4. Over 11 and up 9. Yeah, it's supposed to be a parabola. What did I do wrong? Yeah.
Why does 1 go under the x-axis?
Oh, I did -1, -1. Thank you. That's why I was like, why is that? It looks like a check mark. Yep, me too. Yeah, I was graphing the t. You're not supposed to be graphing the t. You're supposed to be graphing x and y. There we go. -1, +1. Now it's looking a little more like a parabola. Okay. And it's going to keep going until we get out to 1725. I'm just going to throw that point up there somewhere. Does that seem okay, guys?
Yep.
All right. So it's a parabola where maybe this is the vertex, not positive, but we could find that on the calculator. What's the end point over here? And remember, the endpoints are what you get when you put in -2 to both of them and when you put in the 5 to both of them. Okay, to eliminate the t, I have x equals 3t plus 2. Can you get that t by itself? Does that seem okay?
Yep.
Now put it into the y equation for the t, so it says t squared, so we're going to have this. Okay, that's an acceptable answer. I'm just going to rewrite that a little bit. Well, you'd have to FOIL it out, actually. But I'm just going to write this, x minus 2 squared. And when you square the 3 on the bottom, you get a 9, right? Which means there's a 1/9 out here. Does that seem okay? So are those equivalent, guys? Okay, so what's the vertex of this parabola? Right there, 2, 0. Right there. Okay. And 1/9 would make it wide, and it is wide, it just doesn't look super wide, but my scale was 4, remember? All right, so far so good? I haven't really learned anything earth-shatteringly new. Yeah, guess what? This is gonna be new, okay? We're gonna use our calculator. So, whoops, what did I just push? I didn't mean to push that. Stop, go away.
Hey Lucas, hit me up with calculator. Are we gonna be in forward mode? Hey, hit me up.
No. All right, guys, mode. Mode, all the way down, function, and then parametric. Degrees and radians actually do matter for this question. Anybody noticing why degrees and radians matter? It says sine and cosine, and it says 0 to pi. So we're going to be in radian mode. Radians and parametric. Then before we type anything else in, go to your window. It says we want to use 0 to pi. So T min is going to be 0. T max is going to be pi. So I'm going to go second and then this button to get the pi. Do you remember what we always used for the T step? 0.1. Yep, 0.1. You can leave it at 0.13. It won't really matter, but yeah, we may want to do a zoom square eventually. I don't know. But we can leave it -10 to 10 and -10 to 10 for now if you want. Okay, we got to go back to y equals and type this in. 4 cosine, or remember when you hit that button, it's going to give you a t now. And the y is 4 sine t. All right, because the graph is stretched, I don't think I'm really going to get the right picture here. Okay. Why is it only half of a something? We only went 0 to pi. We only rotated halfway around, okay? If I did a zoom square, guys, you're making this difficult to hear. If I did a zoom square, it actually should look more like a what? A circle, yes. It's a circle, it's just that your calculator is stretched. Okay. Oops, I forgot to trace. If we go trace and we put in t equals 0, what is the endpoint we get for an x, y? 4, 0. X is 4 and y is 0. Is that what someone is getting?
Yeah,
Okay. Yes.
I think I might be in the wrong mode because I get instead of 4 0, I get 4 theta equals 0.
Oh, okay. Yep. Go to the top. Shh. Go to the top, guys. Second, zoom. It needs to be in rectangular. You've put it in polar for what we were doing before. Make sure it's basic. I like to call this full left. If you just put all these on the furthest left one, then it's your normal setting. Now when you do trace 0, enter, do you get 4, 0? Okay, excellent. And the other one, when we trace out to pi, so I'm going to go trace and then pi exactly. And I get what? -4, 0 is the other endpoint. Okay? All right, and we can sketch a little graph over here. It was -4 to +4. Would also hit 4 up here, and yes, mine is crooked. Probably the magic of Smartboard. I could scooch it over and make it look better. What do you know? Okay. Eliminate the t. Do you see those 2 stars by number 3? Those 2 stars are there to remind you that this is a test question or something like this is on the test. And it's a little tricky, so you might want to remember to study this. All right. When we have x equals 4 cosine t, and y equals 4 sine t. Getting rid of t is a problem because t is actually a part of the function sine t, okay? We are going to have to trade something. We want to get, just a minute, we want to get rid of t altogether. If we made this into a cosine squared, and we made this into a sine squared, and added them together, we could trade it out and get what? 1. The most famous identity of all, right? Cosine squared plus sine squared equals 1. Now, what we're going to do first, just to make this resemble the next question in as well, is we're going to divide by 4 here, so that we have x over 4 equals cosine. And y over 4 equals sine. Then it's okay to do something as long as you do it to both sides, right? So we're going to square both sides. This will become an x squared over 16. And we square the left side, and the right side will become a cosine squared of t. Do the same thing to the y. All right, this is already gone. So I get a y squared over 16 equals a sine squared of t. Now, this is an odd thing that we're allowed to do, and we're going to do a whole bunch of it in the next unit when we do systems. Remember, you can add 2 equations together. We do it when we do things like this. Remember this? We get 2x equals 15, remember, because the y's dropped out. Well, our goal here is not that something is going to drop out yet, but that we can trade it. We add these and get an x squared over 16 plus a y squared over 16. And over here we get cosine squared plus sine squared, which I don't have room to write. And that whole mess can drop out and become a what? 1. Now this is actually written as though it were an ellipse, right? But if we multiplied through by 16, wouldn't it become x squared plus y squared equals 16? All right. Either of these are acceptable to me. I don't care what you write on the test when it says eliminate t, okay? But isn't x squared plus y squared equals 16 the equation you've got here? Yes.
What's the thing next to the hot mess? That star.
It's a very sad star, yes. That's supposed to be my star.
You should just redraw it. Okay, that's so
See, I don't know that that's any better. My stars are a little strange. All right, moving on. This is not going to be a perfect circle. Type this in and see what you get. See if you can do this problem by yourself. Be careful, they switched the sine and cosine, right? It is still 0 to pi. It's very odd, though. Why is it sideways when it went 0 to pi? Yeah, I think 'cause it has to do with the sine and the cosine flipping. Smart aleck over there. He's way ahead of me always.
Come on, Jacob. Loser.
All right. Now, no, that was very good. What, when we do trace and we do 0, we get what? 0, 2. Now, I'm going to actually trace along this time because somewhere over here, it's going through what? Well, looks like 3 something to me. 3, 0? So is it a perfect circle? Nope. If we keep tracing till we get to pi, which isn't going to happen, until I type trace pi. And then I get 0, -2. Okay, it's kind of tiny on mine, but it goes from 2 to -2, but here it went over to 3. Yes.
So whenever I do this and I trace it to one of the endpoints, it always gives me like 0.1247, -1.99.
Okay. Did you leave your scale for the step, I mean? Go to,
I have 0.1.
you have 0.1 for your step? Okay.
That's not for me too, you just have to trace the exact number.
Yeah, you have to hit trace and then type in the 0 or trace and then use the pi key, I think. Otherwise, it's just getting close, okay? Yeah, and if you were to go look at the table, guys, it would help you with the whole numbers, okay? But pi isn't going to be on your list of t values. You're going to have to just type it in. All right, so this was 0, -2. Okay. Anybody get to the eliminating part? Lexi, is yours not working or?
Yeah, I'm not showing up. What'd you do for the?
Okay, let me come look. Guys, anybody want to come up to the board and do the,
I can do
Okay,
that.
okay.
Good.
finish up the
I can do it like halfway again.
eliminating for me.
No, it's Bill.
Point 1.
Oh.
Hey, Mr. Frey, I have a question.
You can wear them. Say Mr. Frey, please.
Mr. Frey, I have a question.
What's up? Now you
Professor
make it
Frey,
sound like the band.
how did you get X? Where did you get X?
So would this be an ellipse?
I guess.
X equals what?
You did that.
Yeah.
That one was signed.
Was it?
It's okay. They're gonna just add up anyway, but
Yeah, well,
we still don't want to confuse anyone on.
yeah, Heimer's side.
I hope she doesn't watch this out.
All right. And when you add these, this equals 1, and this equals
Perfect. All right, Lucas did a fantastic job. So if Miss Heimer's class decides they're gonna watch this, they will see how smart my students are, right? I'm sure hers are just as smart. I know, it is. All right, we're good. Actually, what Ms. Heimer was concerned about was this side, because she didn't have time to ask me any questions on this side. This is going to switch to the other side. This is still at the bottom of the front, though, right?
Yes.
Remember we did problems earlier this year. If you threw the ball up or you dropped it off of something, you had the height as a function of time. Because of gravity, the height accelerates down, right, which is the -16. This has to do with the acceleration due to gravity, plus the initial velocity that we threw it up or down at. If we threw it down from something, from top of a building, the v sub 0 was negative, but most of the time it was a throw something up. And we had from an initial height. Now, the problem with all these questions is they assume you're throwing something straight up. Well, if I'm going to throw something straight, a ball, I'm not going to throw it straight up because I don't want it to come straight down and hit me on the head, okay? Most of the time when we throw or hit or shoot, we do it at an angle, right? Whether it's shoot a basket or throw something at someone, spitwad, whatever, okay? Or what happens when you hit a baseball at an angle to the ground or hit a golf ball,
Bounces up.
okay? So, The issue here, guys, imagine this is a golf ball, hit it with an initial velocity of 140 feet per second. So the path it leaves makes a 31-degree angle with the horizon, or the horizontal line there. Imagine the golf ball starts at the origin and travels in a direction of the positive x-axis. If there is no gravity, the distance it traveled would be a function of x and y, okay? Vectors, does this look familiar? 140 cosine 31 and 140 sine 31? Remember the vector components? X equals 140 cosine of 31. Does this look familiar? 140 sine of 31. Okay? Guys, please stop talking. Okay? We have to put these into our fancy equation that we started with. Y equals negative 16t squared plus v sub 0 t plus h sub 0. Okay? This x component is going to be what's causing it to go this way. We're going to write that here. 140 cosine of 31. And I'm going to put the t at the back. I think the book usually puts 140t cosine of 31, just so you know. And back here, this y is affecting the height here. We're going to put it here. So it's negative 16t squared. I'm going to go over that because I don't want you to forget that's there. Plus 140 sine of 31t. And now this was off the ground, so there is no initial height. So this is just 0 for h sub 0 back here. All right. Before we try to type this in, we need 3 things to think about in terms of the x and the y, or in terms of graphing. T is time. When you hit a golf ball, what do you think? How many seconds till it hits the ground?
Sure. 4.
2, 3, 4. We could try 4, okay? I wouldn't start out with 10 because do you remember the calculator has to calculate all this stuff and it takes forever? If it stops in midair, then you know you need to add a little more time, right? So I would start with something small. This is a golf ball. I think it's going to go pretty far. X is how far away from us it goes in feet. I don't know, somebody throw out a number.
200.
200 feet, okay? How high does it go?
300.
I don't know. I think those might be backwards in terms of proportionally, but let's try it. What mode are we in now? Uh-oh. Mode problem.
We go to degree, right?
We need to be in degrees, but we are still in parametrics. Degrees. Make sure you go to degree mode or this isn't going to work. All right. The first one, x, is just the component. So it's 140 cosine of 31. Close your parenthesis and then put your t, or you can put your t out in front. And this one is negative 16 t squared plus 140 sine of 31. Gotta have a t after that. Close your parenthesis and put a t. And then there is no initial height, so we won't have anything to put on the back. All right, we're gonna go to our window. We are talking time this time, so we said we'd try 0 to 4 seconds. I'm gonna leave my t-step 0.1. X is distance away from me. We decided to start with 0 to 200. Scale doesn't really matter. And Y is height. It's not going to go underground, so 0 to 300 was Jacob's suggestion. Okay, graph.
We need to keep going.
Okay,
1,000.
we need to move. Which one do we need more of?
X.
X. So I'm going to change the X max. We can go 1,000. Okay. Uh-oh. It stopped in midair, so we need a little more what? Need a little more time. So I'm gonna go 0 to 5 seconds or 6 seconds should be fine. All right. So I'm gonna erase this. Did anybody find a window that's really nice? I mean, this works, but
I think 0 to 100 for the Y.
100 is high enough?
Yeah.
Okay.
Oh, yeah.
And like 800, 700, 600 works? Okay. As long as it's in the realm, it shows up on the screen, your answer on your test or quiz will be fine. Guys, this is part of the test, okay? If you put down negative 10 to 10 and negative 10 to 10, I'm not going to count it right. We don't need negative time. We don't need negative x-axis. We don't need negative y-axis, okay? So be reasonable here. Now, do trace. When you do trace, this is where it starts and this is where it is at each time. What is the highest it ever gets? Can you try to figure out about where the peak is? And you can't do max with this. Look at the y value. What's the highest it ever gets? 81 something?
81.2.
Okay. So it goes about 81 feet up in the air at 2.3 seconds after we hit it, right? And at that point, it's about 276 feet away from us. Everybody understands that x is distance away, y is height, okay? Keep going till it hits the ground. What do you want to be 0 then? You want to get the y value as close to 0 as you could. 540 gets me pretty close. So, question, how long is it in the air? Right here it says 4.5 something, right? So about 4.5 seconds and it hits the ground. How far away from me does it land?
530, 530.
I got 540-ish, and it will depend exactly, I have to give you some leeway on this, because you can't get it. If you wanted to be a nerd like me, you could go trace and put in like 4.41, 4.42, and see how close to 0 you could get that.
How can you even tell with the water there?
Yeah, my axis isn't in very good shape here. Is it 4.5 something? Is that why I'm not doing so well? What did I just do?
Zoom fit?
Okay, didn't mean to do that.
No, you didn't hit zoom fit.
I hit something that did a mess. All right, when does the ball hit the ground? Somebody have a better answer than me? It's about 4.5, 4 point... Okay. That's what I was doing 4.41 instead of 4.51, like a crazy person. How far from the starting point does it land? What was the X?
540.
Around 540, was this feet? Okay. So what is the maximum height? We said it hit a max somewhere up here of Y value at... Okay. Now, those are estimates because our calculator in parametric mode doesn't let us calculate a 0 or a max. Okay? One more question. This one's really fun because I'm going to show you. Oh, on your picture here, just draw yourself that this is our cosine of t, our cosine of theta, and this is our sine of theta. Okay? It's related to the magnitude of the vectors. Remember that? Okay. I want to do this last question because it says a batter hits a ball 3 feet above the ground. So what is that telling us? H sub 0 is 3. Okay? So we're going to put a plus 3 on the back. The ball leaves the bat with an initial velocity of 138 at an angle of 26. So what goes on this blank? 26t. And back here, it's negative 16t squared plus 138 sine of 26t plus 3. All right. Appropriate window. Give me a guess. 300 feet away? High? It says there's a fence 400 feet away, so I'm thinking it's gonna have to be more like 500 feet away here. Height? What do you think? 100 is enough, maybe? 5 seconds? I don't know. Let's see if that works. And then I'm going to teach you to draw the line. That's the fun part on this question. 0 to, what did I say, 500 feet away, maybe? 600 is better? Okay, thank you.
I just left the window and it looks good in the last.
Oh, I wasn't that smart. Remember, I messed my window up, so.
Yeah, 0 to 600, that's what. Or no. 0 to 100, that works.
Okay, it was 138 cosine of what?
26 G.
Okay, so our angle was 26. And this one needs to change to 138. And we need a +3 on the back, right? Because it came off the bat 3 feet above the ground. All right. There's the ball. Path of the ball. Actual path of the ball this time, right? Because it really is doing a height up and down. Now, the easiest way to answer the question about the bat, about whether it clears the fence, if the fence is 400 feet away, what do we want to do? Trace out to 400 feet. So 400 on the X or the Y, guys? It's going to be a problem if you try to do Y. 400 on the Y. When you get out to 400, it's about 32 feet in the air still, right? Will it clear the fence that's 25 feet tall? Okay. Yes?
Yeah. That's 33 feet.
So out here somewhere is a fence. How far away did it land? Can anybody tell me? It started 3 feet.
496.
About 500 feet away it landed. Okay. And how high? Did anybody figure out how high it went? Didn't ask us this, but
About 68.
about 68 feet up. Anyway, just an estimate. We want to draw, I want to show you how, just for fun, to draw the line on your calculator, okay? Everybody go to the home screen. So quit out of this. And there is a draw feature on your calculator. It's second program. Second program. And we're gonna go to draw a line. Okay? No, we're not gonna free draw this. If,
68.
okay, I didn't look, so I can trace that in a second. Go to the home screen, second program, draw, pick draw line. We need the endpoints. All it's doing is you give it 2 endpoints and it connects it. So one is 400 feet away, so 400, 0, comma, 0, comma is above 7. And then we have to put a comma and then the height of the wall. So at 400, we need to go up to 25, above the 7. So we're going to go 400, comma, 25 is the other end. Okay, hit enter and all it says is done. It wasn't very exciting, but then it should go to the graph. Or if you go to the graph now, there's a wall and it shows it going over. How cool is that? Okay, now I'm going to trace along because Ben said he didn't get this answer. What was the height? Yeah, I only got about 60 feet, not 68. Okay. So this one should have been about 60 feet. But yes, height at x equals 400 is about 32 feet. So it clears the wall.
This hot bar, could you like make that little ball go across this so it looks like it's
Oh, yes. We're going to turn the little ball on. If we go back here, go to, okay. Okay, you go back arrow when you're in the x equals. I'm gonna actually do the one that doesn't even trace, that just shows the ball. Here it goes. Dun, da, da, da. Okay, yep. The line goes away. It's okay. If we go second, back here, quit, and hit enter again, it'll draw the line. Oh, it didn't make the ball go again, though. I don't know if it's gonna work now.
Maybe we should have it draw the line.
Wait, the line, all my lines are gone.
Now it doesn't want to do it again. Okay, I'll turn it back on here.
Okay, you gotta turn the line with it on and then
If you turn back and forth between one and the other, ah, the line is gone again.
the, okay, no,
The
no,
wall is gone.
The line will come up after.
It's the shoe
Wait.
across my stomach.
Okay,
Wait, did you hit enter
I'm
on
gonna
the home
quit.
screen?
Go enter on the home screen. There it is.
Oh, yours didn't draw it.
But as soon as I tell it to redraw it, it doesn't draw that line, I think. Okay, we need to stop recording because this is ridiculous. We're just playing around.